So one of the first patterns, and this has been popular for a decade, it started with high-valued assets in particular, but it's remote maintenance and diagnostic centers. This is where ICS data from the field, from your sites, is moving up, and the whole idea is get it in front of subject matter experts. It's your turbines, it's your jet engines, and so forth. This usually comes through a historian, but it could come through any other kind of middleware as well. Know your threat model. Know what can go wrong. Are you fusing two giant networks together with a VPN? That sounds a little hazardous. What about functionality like file transfers, remote desktop? Those things should make the alarm bells go off. Dig into the data flow, really analyze it, understand what's going on. And of course, have a plan. When NotPetya, WannaCry is floating around, know how to open the drawbridge. Know how you're going to disconnect things. IIoT. This is still open loop. Now you'll notice the way I've drawn it here. This is completely outside the box, completely separate. We are not plugging our IIoT devices into the protected area. We've got a separate exfil point for the sensor data, goes right into an IIoT platform, and this is pretty awesome. Why? We're lighting up dark data. This is data that's never been available to your company before. You can make lots of money if you have this data. Oh, historian as a service. My favorite thing, this is kind of what OSIsoft does, is historian business. The key here is about getting fewer people inside that critical perimeter, right? The more people you can move outside the perimeter, the safer things will be. My first closed loop example is what we call forecasting models or soft sensors. Either of these will allow you to close the loop and leverage cloud resources. What do you do with that data when you get up there? Well, you run some really cool analysis on it, and you send maybe a set point back that gets used in your control loop. And the key here is now the data flow is bidirectional, which means that's your attack point. If some bad data comes in here, that's when things can go wrong. At a very, very minimum, the data that comes back in from any kind of model, any external source, has to be value checked. You're going to want to do more than that. If you're a good control engineer, you're going to have keep alives, you're going to have all sorts of checks on that data that comes through. You might even put an operator permissive. Make sure an operator looks at it. Is it okay to use this value? What about SCADA as a service itself? This is available on the market today. All the major automation suppliers offer this approach that the edge devices have to be autonomous. There has to be some level of autonomy at the edge, otherwise you'll never be able to trust any of this. We need to come to grips with the idea that cloud and ICS has a place in our future. We don't exactly know what will be the most successful things, but I'm convinced beyond a doubt that being transparent about where the risks are in the system are a key ingredient.